You are watching AliAziz Quality Education YouTube channel.
Engineering Physics in BSc Aircraft Maintenance Engineering Technology, AMET. By AliAziz Quality Education.
AliAziz Quality Education channel, providing you the aviation industry related videos. So don't forget the subscription button.
Engineering physics is a foundational subject in the AMET program that blends core physics principles with engineering applications. It helps students understand the scientific mechanisms that govern the operation, maintenance, and design of aircraft systems and components. Why engineering physics is important in AMET. Aircraft maintenance engineers work with highly complex mechanical, electrical, and structural systems. Engineering physics provides the theoretical base to understand aircraft behavior in flight, solve technical issues related to mechanics, thermodynamics, and electromagnetism, ensure compliance with aviation safety standards. Purpose of studying engineering physics in AMET. Aircraft are complex machines operating under extreme conditions such as high speeds, variable atmospheric pressure, and temperature changes. Understanding the physical laws governing these conditions is essential for diagnosing technical issues, ensuring operational safety, performing accurate maintenance, innovating and optimizing aircraft systems. Key topics and their aviation applications. Topic: Application in aircraft maintenance. Mechanics, kinematics and dynamics. Used in flight motion analysis, control surface function, landing gear operation. Work, energy, and power. Crucial for calculating engine output, fuel efficiency, and hydraulic systems. Properties of matter. Helps in understanding material strength, fatigue, and deformation in aircraft parts. Heat and thermodynamics. Applied in engine operations, environmental control systems, ECS, and fuel systems. Waves and vibrations. Important for analyzing noise, aircraft vibration, and acoustic signatures. Optics and lasers. Used in avionics, cockpit displays, and alignment tools. Electricity and magnetism. Fundamental for electrical circuits, alternators, and communication forward/navigation systems. Modern physics, quantum and nuclear. Applied in advanced sensors, GPS systems, and radiation safety for avionics. Real-world aviation applications. Landing gear system. Involves principles of dynamics, energy conservation, and pressure systems. Jet engine function. Based on thermodynamics, fluid dynamics, and heat transfer. Flight stability and control. Physics of motion helps in assessing aircraft pitch, roll, and yaw. Aircraft electrical systems. Concepts of electromagnetism used in troubleshooting and maintaining systems like lighting, avionics, and fuel sensors. Material testing. Stress-strain relationships determine airframe and component safety. Hands-on learning and practical labs. Students will gain practical exposure through physics laboratories, experiments on forces, motion, thermodynamics. Use of aircraft simulators and diagnostic tools. Testing material strength, elasticity, and deformation. Electrical circuit design and fault detection exercises. Role in aircraft maintenance. Engineering physics is deeply integrated into routine maintenance, electrical checks, fluid levels, structural inspections, performance evaluations, engine thrust, hydraulic pressure, safety systems, fire detection, de-icing mechanisms, pressurization. Advanced technologies, fly-by-wire systems, radar, autopilot. Skill development through engineering physics. Scientific problem solving. Technical interpretation of aviation systems. Diagnostic and analytical skills. Application of physics formulas in engineering contexts. Use of simulation tools and lab equipment. Career relevance. Employers in the aviation industry expect aircraft maintenance engineers, AMEs, to grasp physical principles behind system behavior. Work confidently with diagnostic technologies. Communicate technical problems clearly. Contribute to aircraft design improvements and maintenance strategies. Conclusion. Engineering physics serves as the scientific backbone of aircraft maintenance. It provides students with the ability to understand complex aircraft operations, solve engineering problems efficiently, make decisions based on physical laws and safety regulations. Mastering engineering physics enables future engineers to maintain high standards of performance and safety in the aviation industry, making them competent and confident professionals.